Hello boys and girls, this is Miss Hanamio, and I'm going to have us take a look at our DMA for day 3, week 22. So let's take a look. I've zoomed in on our paintbrush here so that we can take a really close look at where that paintbrush ends on our ruler. So you'll notice that we started the ruler the paintbrush at the end of the ruler. And these are the whole inches. So that's 1 whole inch, 2 whole inches, 3, 4, 5 whole inches. Now, it's not exactly on the 5-inch mark, and it's not exactly on the 6-inch mark. So we know that since it's a little bit past this 5-inch mark, then the rest of this from here to here is going to be a fraction of that whole. Now, when we look at a fraction of the whole, we put the whole number first. So we could say that this is 5 whole inches, and then it's a little bit more. Now, this line right down the middle, that's our half mark. And the next longest line on either side of those are the 1/4 inch marks, or the quarters. We call those quarters because remember 1/4 is also could be called a quarter. Like remember on our clock, we talked about a quarter of an hour would be at the 15-minute mark and the 45-minute mark. So we can also look at a ruler the same way. This would be a quarter and this would be a quarter on either side of that half in the middle. So right here, it's lined up with this quarter mark. So we could say it's 5 whole inches, and a little bit more would be 1/4. So it's 5 inches and 1/4. So 5 and 1/4 inches. And I'm just going to put the inches down here or here. So it's 5 and 1/4 inches. Okay? That one was a little tricky. Now let's zoom out. And now I'm going to take a look at, we're multiplying 6, a single digit, by a multiple of 10. So a couple of different, a couple of different ways to look at this. We could start with the basic fact of 6 times 7, and 7 times 6 or 6 times 7 is 42. If we know that 7 times 6 is 42, then 70 times 6, it's like multiplying by 10. So each one of these place values is going to go to the left by 10 times more. So 7 times 6 is 42. 70 times 6 would be 420. Or you could also think of it this way, 7 times 6 times 10. Because what is 70? It's 10 times 7, right? So it's actually, we could even think about it as 3 factors instead of just 2 factors of 70 times 6. We could think of it as 10 times 7 times 6. And remember, it doesn't matter the order that we multiply in, it's just going to tell us that we're going to get the same product. So this would be 420, which means when I multiply something by 10, each place value goes up 1 more place value. So that 2 becomes 20, and that 40 becomes 400. Right there, 420. Okay, let's take it 5 times 9. 5 times 9 is 45. So if I were to do 50 times 9, which is multiplying it by 10 times more, then that 5 is going to become 50. That 40 is going to move to 400, and that's going to give us 450. Let's take a look at this next one. How many groups of 80 how many groups of 80 would it take to make 160? Well, one group of 80 is 80, right? What's 80 plus 80? Well, if you said 160, you'd be correct. So let's think about counting by multiples of 8. 8, 16, 24. So we could do the same thing here with our multiples of 80. We could say 80, 160, 240. So it takes two groups of 80 to make 160. So our missing factor here is going to be 2. And then finally, it's asking us, and we're going to use the number lines on here. So I'm just going to fill in my number line. It's telling me here's half. So here's my halfway mark right there. And it's asking me true or false. The fraction half and 3/6 are equal. Well, if I were to take a whole and break it up into 6 equal pieces, I notice here I have 1/6, 2/6, 3/6, 4/6, 5/6, and of course this would be 6/6. But if I look at where the 3/6 and the half are, what do you notice about where they are on the number line? They're in the exact same place, aren't they? Also, if you take a look at your fraction bars, and we're going to work on this next week with equivalent fractions, but just to take a look at it using our fraction bars, we could also take our 3/6 strips. So if I take 3 of my 6ths and I compare those 3/6 to my half bar, you will notice that 3/6 is the same as 1/2. So using what you know, using your fraction strips, you can also use the fraction strips to compare on a number line and using your fraction tiles, or they call them fraction strips. So using what we know about that, this is going to be true, that they are equal to each other. And we're going to start looking into this idea a little more as we start to compare fractions more and more in our future lessons. So today, I'm not going to give you necessarily a clue word today. I'm not going to give you a problem to do today, but I do want you to take a look at your fraction strips. So I guess it kind of is a problem. I want you to look at your fraction strips, and I want you to give me one more fraction that is going to be the same length as half. So besides the 3/6, pull out your fraction strips and give me another fraction when you line them up that's going to be equal to half. Play around with those fraction strips a little bit today and see what you can come up with. Is there another fraction that when you line it up with half, besides the 3/6, you can't use 3/6 because we've already used 3/6. Are there other fractions that you can find that are equal to the same as half? And that's your problem of the day. So find another fraction that is equal to half and not using 3/6. Okay, can't wait to see what you guys come up with. Do a little bit of playing with those fraction strips and see what you find. Have a great day, and we'll discuss this idea on Thursday.